Okay, hello everyone. My name is Yudhistira Putra Irfianto. I'm from Geological and Engineering batch 2024. In this video, we're gonna explore how grain size and sorting act as a key indicator of energy condition, paleocurrent direction, and the length of sediment transportation. These three small physical properties of sediment might look simple, but they actually contain valuable information about the ancient environment in which the sediment were deposited by analyzing how large or small the grains are, how well they are sorted, and how they are arranged with the layer. So, geologists can reconstruct the process such as river flow, ocean current, wind pattern, etc. So, let's break down how grain size and sorting reveal the dynamic story of Earth's surface. Before we continue, my name is Yudhistira Irfianto. My student number is 24 slash 546472 slash TK slash 60765. And here are the reference that I am using in these slides. We have Box, Principle of Sedimentology and Stratigraphy, and Nichols Sedimentology and Stratigraphy. First, introduction. Why are grain size and sorting is very important in like they are the parameters of ancient environment. So, grain size and sorting are two of the most important textural properties used to describe sediment and sedimentary rock. They provide key information about the depositional environment, such as how strong the water or wind currents were, how consistent the energy remained over time, and in which direction material were moved. By analyzing these two characteristics, geologists can interpret how sediment were eroded, transported, deposited, helping to uncover the dynamic story of ancient environment. So let's move on. First, the grain size. Grain size refers the diameter of individual sediment particle and is commonly classified using Wentworth scale. For example, like in the picture on the right side, which is range from clay to gravel. The size of grain is directly related to the energy of the environment. Fine grained material like clay and silt settle in calm, low energy environment such as lake, deep marine, basin, etc. While quartz grain like sand, gravel are deposited in high energy such as beach, delta, etc. Those grain serve thus grain serve as a direct reflection of energy condition during sediment deposition. Let's move on. Now is the grain size and energy relationship. The relationship between grain size and energy is straightforward. The stronger the energy, the larger the grains that can be transported and deposited. High energy flow, like those in mountain, rivers, or coastal surf zone, can move coarse sediment, while low energy settings allow only fine particles to settle. When the energy of the system changes over time, we can often see this in the sedimentary layer. A fining upward sequence indicates a decrease in flow energy, while coarsening upward sequence shows that energy increased during deposition. This pattern would reveal how energy fluctuated during sediment accumulation. As you can see on the right side picture in the ABC is grain size, meaning in the A, meaning that it is a low energy, while in the medium, in the B picture, maybe it is between low energy and high energy flow, while the C pictures on the right side, as you can see, the grain size is very coarse, so meaning those grain are undergo a high energy flow. Now we move to the grain texture. In the grain textures, as you can see, there are two parameters, roundness and sphericity. The difference is roundness is how smooth the surface are on the outside part of the grain, while sphericity is look like how much it looks like a ball. So how much it's look like a ball. So by this parameter, it can also indicate or interpret a ancient environment. For example, if your grains are having a angular form and low sphericity, as you can see, the energy will be high and the transportation time it will not be taken that long. But reversely, if you have a well-rounded and high sphericity grain, you will have a low energy transportation and the grain are coming far from the source. So they are transported already very long. Okay, so we move to the paleocurrent indicator. Paleocurrent analysis focus on understanding the direction of ancient flow systems such as river, tides, or wind. Certain sedimentary structure preserve evidence of this flow direction. One example is cross-bedding, as you can see in the right picture, where inclined layers of sediment are deposited by moving current and the direction of the inclination point downstream. Another example is ripple marks, which are small undulating features formed by flowing water or wind in a symmetric ripple. The gentle slope faces upstream and the steeper slope faces downstream, showing the direction of the sediment transportation. Now we move to the second paleo indicator. Another useful indicator of paleocurrent direction is imbrication, which is commonly observed in quartz, gravel, or conglomerates. In this feature, flat pebbles or elongated grains overlap each other in the direction opposite the flow, leaning upstream. These arrangements occur as the current pushes grains into a stable position by combining evidence from cross-bedding, ripple marks, and imbrication. Geologists can interpret not only the flow direction but also the relative energy and consistency of each current. As you can see in the right picture, the grain size is leaning towards right, as you can see. So we can interpret that the flow direction is coming to the left, and if you can see the lean is very down, as you can see, it means that the energy is very high. Now we move to the second parameter. What is sorting? Sorting describes how uniform or varied grain size are in sediment sample. Well, sorted sediments have grains that are nearly same size, usually formed in the environment with consistent energy such as beaches, dune, or shallow marine. In contrast, poorly sorted sediment contain mix of grain size and are commonly produced by rapid or variable energy conditions such as glacial deposit, debris flow, or alluvial vent. Sorting therefore reflects both the constancy or flow energy and the process of sediment deposition. As you can see in the right picture, the very poorly sorted, the grain size is not the same size. So it has like the big one, very small one, medium one, continuously to the right, poorly sorted, moderately sorted, and well sorted, and very well sorted, meaning that very well sorted, the grain has all the same grain size and it undergo a long transportation. Now we move to the sorting and transportation time. The degree of sorting also provide information about how long the sediment were transported and how stable the energy conditions were during movement. In long, continuous transport under steady flow, sediment become progressively better sorted as finer grain are carried away and coarser grain gets settled out. As you can see in the below picture from the left to the right, it explains like what are how our sorting can tell us like the engine environment of the earth, like the Paleocurrent, depositional environment, etc. Now we move to the interpretation analysis. By combining observation of grain size, sorting, and sedimentary structure, geologists can accurately interpret the nature of ancient environment. Quartz and poorly sorted sediment typically indicate high energy, short duration, even such as river, channel, or glacial outwash. While fine and well sorted sediment suggests long term deposition under stable low energy conditions like beaches or windblown dunes. Very fine grained and laminated sediment, on the other hand, are associated with quiet, deep marine or lacustrine setting. Together, this clue allows scientists to reconstruct how and where sediments accumulated over geological time. Now, in the last one, in the conclusion, grain size reflects the energy level and transport strength of an environment, while sorting reveals how steady energy was and how long the sediment were in motion. Sedimentary structure, such as cross-bedding, ripple marks, and imbrication, provide additional evidence for flow, direction, or paleocurrent. By analyzing all these aspects together, geologists can decode the physical process that shape ancient landscape. Every grain holds a piece of Earth history, recording erosion, transport, and deposition that occurred millions of years ago, helping us understand the evolution of our planet surface environment. That's all from my explanation about grain size and sorting can help us interpret like how to see the paleocurrent deposition environment and transportation time. My name is Yudhistira Arya Putra Irfianto. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.